Okay, so we're starting our new topic today, and it's recursion and financial modeling. So recursion is just a way of, it's sort of like a descriptive way of explaining sequences and things like that. So it's really just a style of language used for rules and formulas and stuff. So we call it recursion because it's how we get, say, the next thing recursively means coming the next one after the next one, things like that. All right, so let's just have a quick look at the start here. So Johnny wants to save money for the future by investing in a low-cost listed investment company, Argo. Each week, Johnny is given $250 a week for his part-time job, and he deposits it in a share fund and gives his parents also give him $500 to start his long-term savings plan, assuming no dividends are received. So that sort of dividends are like extra interest on shares, but so they're saying assuming no are received. So that scenario here, I've written it in a recurrence relation. So you'll see when you have a recurrence relation, you'll see they always give you the starting value, and they symbolize that with a VO. So if you want to, so VO is always like the starting value. Okay, so we write it down later on, so don't stress too much. But then, so he's going to start off with the $500 that his parents gave him. And then what happens every week, he's with his job, he's putting $250 in. So here's the recursion. This is the recursive language there being used. So instead of me writing it all out in words, mathematically we would write this. So that Vn plus 1 is how you get the next term. That's what that means. This is the rule of how he gets the value of his next, like every week or whatever. So every week he takes what he has the week before, and then he adds the 250. And you can see that. So if we were going to find the next week, we'd take 500 and we'd add 250, which would be, so if you say like that, so say at the start at VO, the value was 500. If I go to value after 1 week, he would have 500 plus the 250, so he'd be 750. Then if you go to V2, it would be the 750 plus another 250, which would be 1,000. Okay, so then you just keep going, and that's like what recursive means. You just keep going and going. The same rule, the same pattern is going along. Or you could look at it as a sequence. So sometimes we talk about it as sequences and recurrence relations. That just means we're using that wording. We're going to use, so if you want to write down under in brackets, this is when we're going to use VO, Vn plus 1. We're going to use all those sort of terms to describe it. We don't write it out in words, sort of thing. So we've got a sequence here, and here we look at it. So a sequence is a list of numbers, and each number in the sequence is called a term. So here, this is like, we call it, often they just say T, that's term 1, that's term 2, and so on. So at the moment they are showing there, they've got 5 terms showing there. So in the sequence, they're showing me what's happening if this was written out, this sequence, it would just look like this. But so what's happening in the sequence, the rule is that every time 2 is getting added. So if I was going to just, for example, I want to write that out recursively, I would say, all right, my initial term was 1, and how you get the next one is you take the one before, so that would be the one before, and you're going to add 2. So that, if you look at that, that is me writing up a recurrence relation. Okay, so that's what that means. If I write it out like that, that's a recurrence relation. So that's the recurrence relation for that sequence, okay? So a recurrence relation always has a starting point. So let's just write in there, like I'm saying VO, we'll often use V meaning value, because we're going to be talking about money and finance. So we often use V, but sometimes they can use another letter, and they'll use a capital with a little zero to say that's the first, number of your term, or that's the first term. So we'll see that in a few examples. So then we have the second thing we have in a recurrence relation is the rule. So just so you know, remember, that's when we're going to have Vn plus 1 equals, and we'll have the term before, and then you'll have some type of instruction on what to do. So that's the rule. Okay, so if we got another example there, we've got a starting value of 10. So you can see here they wrote VO is 10, and they said the rule to get the sequence, or the sequence for this, is to add 5. So you add 5 to the one before. So if I was writing this out as a sequence, I'll just do it here. I'd have 10, then I'd have 15, then I'd have 20, and so on, yeah? So that would be what the sequence is. This is the recurrence relation for that sequence. Like, that's what that is. So a sequence is generated by a recurrence relation. So we can see that. So here's an example of another one. Now, it's got 300 is the starting value, but then what we've got to do is to get the next term, we've got to times it by 0.5 and then minus 9. So some of these are starting to get a bit ugly. We probably can't do them so easily in our head. So what you want to do, so I'm going to show you how to do it on the calculator. So if you just have a look here, so you put over on the calculator, when you're doing a recurrence relation, you just want to get the sequence up. Say I want to get the next 5 terms of this sequence. So you always start with, you put the first number in, the VO. So I've put 300, and then I want you to press enter. So it drops the 300 down over here on the right. So once you've done that, you watch, your cursor will end up down here. Now, because I want to times it by 0.5, because that's what this rule is telling me to do. So because I want to times it by 0.5, all you have to do now is press times, and it should bring up answer, which it does. So when the calculator writes that, it thinks that what it's thinking is that you want me to the line before, the 300, which is what I want it to do. So I've pressed times, and I want to times it by 0.5, and then I want it to subtract 9. So let's have a think about it. What number should we think we see? We should see 141. So press enter. There we go. Now, once you've done it once, all you have to do is keep pressing enter. So if I keep pressing enter, it's bringing up that sequence there for you. So you don't, once you've done it the original time, you don't have to keep going. So here, I could write out the sequence. I'll just write it underneath. So we got 300, then we had 141, 61.5, 21.75, and so on. So this was VO. This could be V1, V2, V3. So when we talk about the value, so value, when we say V1, we say value after one, whatever, one period or one ruling thing. If you ask for the first 5 terms, see here, they said write down the first 5 terms. So in terms of terms, I just need to put one more, because VO is a term. So if you look at it here, I'll just do it in another color. So they asked me for the first 5 terms. So I've got 1, 2, 3, 4. So I actually just have to do one more. So I needed to write down one more, which was 1.875, which is actually only V4. So it's the value after 4 goes, but how many terms in the sequence, it's actually the 5th term because the original is counted as a term. Okay, so yeah, so moving on. So that's how you would do it on the calculator. Now, here's a couple of exam questions. So they start off, these always start off the finance sort of part of the exam. So you'll get so they're pretty easy. So let's have a look here. They said let's get the first 4 terms of this recurrence relation. So I'm just going to do it. I'll do it like manually, and then we'll do it on the calculator to practice. So if you have a look, if I was writing the first 4 terms, so remember I said 2 that's the first one, so we would have 2. Now over here, so here's where I'm telling you they haven't used V. You'll see I often use V, but they wanted to use A, so that's okay, A. So A1, so how I get the next term is explained there. I have to do 3 times the term before, which would have been A0 plus 1. So if you think about it, that's 3 times 2 plus 1, which would be 7, okay? Now, if I was getting A2, it would be 3 times the one before plus 1. So it would be 3 times 7 plus 1, which equals 22. So if I'm talking about, so I've got 2, 7, is that right? So 2, 7, 22, and then the next one, so A3 would be 3 times 22 plus 1, which would be 6. Whoops, I just went quick. 67. So E is going to be my answer. Because they said the first 4 terms, remember the original counts as a term. So here's term 1, term 2, term 3, term 4. So just to give a little refresher on the calculator, just to show you, this one's pretty easy. You could do it in your head, but let's go. We go 2, press enter. Then I'd say times by 3 and plus 1, and then I go 1, there's term 1, 2, and there's 4. So I was correct, okay? So that's how you do that. So let's have a look at the next one. So here we want, what's the value of P3? So if I was to do P1, it would be 3 times PO minus 1. That's the formula, which would be 3 times 2 minus, minus 1, which is 5. And then P2 would be 3 times P1 minus 1. So it would be 3 times 5 minus 1 equals, what's that, 15 minus, did I do that right? So 3 times 15 is 14. Oh, we want P3, so I've got to keep going. So 3 times P2 minus 1 equals 3 times 14 minus 1 equals 41. Okay, now, just to, so this is a multi-choice exam question. Just to go over what you would be doing on a short answer exam is they will say show recursively how P3 is found. So if they say that on a short answer, you have to show that working out, okay? You must show that you used the term before. So we'll come across them in some practice things. I'm just going to pause it and let you have a go at those next 2 questions because my video is going to run out.